When the Human Genome Project was completed, everyone said it would revolutionise medicine. You'd be forgiven for thinking it changed nothing, but you'd be wrong. Things have come a long way since then. Genomics is going to be fundamental to the future of healthcare, transforming outcomes for patients. The specialist genetics workforce is using genomic technologies and it's already having an impact on care. But this is now everybody's business. Health Education England is launching a major new educational programme to ensure that you, the workforce, are ready for this exciting future. But let's start with a bit of background. So, your genome. It simply means all your genes. Think of it like this book, except it's unique to you and it contains all the information needed to make you, run you and repair you. Reading your book, letter by letter, uses a technique called sequencing, and doing the first one, the Human Genome Project, took 13 years and cost £2 billion. Now it can be done in a day and costs £1,000. And it's that giant leap in technology that's making genomics a reality for you now. While science has been looking at the whole book, clinicians have tended to focus only on those chapters which they already know are important to human health. But as scientists understand more about the whole human genome, the significance and potential of the entire book are becoming clearer. Right now, genetic scientists tend to use these, they're called arrays, to check just a few genes of interest, rapidly guiding treatment. The study of the genome plus all the associated new technologies are together called genomics. We all know about changes in the genes we inherit and the devastating diseases they can cause. Clinical geneticists diagnose those affected and counsel them and their families. But genetics is moving out of specialised services into more everyday clinics and more common diseases. Take diabetes. Currently, we put everyone with diabetes in more or less the same box, treating them in much the same way. But now, genomics is showing us a new way. It's revealed a type of diabetes which is better controlled with these simple tablets than these. Simon here has diabetes. He's been injecting insulin nearly all his life.
It will be these tablets instead of your insulin.
Wow, so no more needles? That's brilliant.
Simon's very happy. Through the use of genomics, he's now being treated more effectively and more cheaply. There are thought to be another 30,000 Simons out there in the UK yet to be discovered. And there are many other common diseases where genomics can show the road to better treatment. When genes in cancers began to be sequenced, there was a big shock. Every cancer was different. And how a cancer responds to drugs depends on its particular mix of gene changes or mutations. That's why oncology has already embraced genomics. The best known examples are for melanoma and breast cancer, but now it's being used for others like lung cancer, where it's beginning to give extra years of good quality of life to some patients. Genomics means better outcomes for cancer patients. It means expensive drugs are only given to those who will benefit from them. And it'll even identify patients who'll do best with fewer radiotherapy treatments. But this is where it gets really exciting. In the past, to do the sort of genomics we've been talking about, you needed specialised genetics labs. But this, well, this is a molecular laboratory in something the size of a shoebox. It comes with a range of cartridges which allows you to identify specific genetic changes in about 15 minutes. That's virtually instant results. It puts genomics in your hands, helping you to decide the right treatment for your patient immediately. And then there's bugs, TB, C. difficile, or these ones, MRSA. Very little things with very few genes, but whole genome sequencing has shown us that whilst they may look the same on the outside, on the inside they're very different, and that's killer information. Whole genome sequencing of MRSA tells you the type, helps you with tracking, and identifies people who need to be treated. Recently it was used to stamp out a mystery outbreak that threatened a whole neonatal unit. Imagine a test that will guide you to the right antibiotic for an infection within 15 minutes. No, don't imagine it. It's already here and in use. The size and ease of these molecular labs in a box make them suitable for use in wards, in ambulances, or like here in a GP surgery, say for high cholesterol.
The genetic test that I've just done suggests that your high cholesterol level that we discussed is likely to be running in your family. Do you have any brothers and sisters?
Yeah, I do have two brothers aged 10 and 12.
The test has found a genetic variant which causes high cholesterol. People with this variant benefit from having statins from early childhood to protect them from future heart attack. It's thought that there might be as many as 200,000 youngsters whose lives could be dramatically changed if only they could be found. The ease of GP testing using this genomic kit could find them more quickly. So do you still think the Human Genome Project changed nothing? And these have been just a few examples from the rapidly moving field of genomics. In 2012, the Prime Minister announced the 100,000 Genome Project, which will bring genomics centre stage and into the public view. It's going to create a technology platform which will bring cheap, rapid whole genome sequencing to everyone, helping us to understand disease and personalised treatments.
Health education in England exists for one reason only, and that's to improve the quality of healthcare delivered to the population through a focus on the education, training and development of the current and future healthcare workforce. The genomic revolution is critical to the personalisation of healthcare, to the prediction of disease and the prevention of disease, and that's why we will make sure that we train not just our current workforce but our future workforce in the skills they need to be able to respond.